Welcome to track 4, Mobile. This is Adventures in Bouncerland, presented by Nick Percoco and Sean Schulte.
Okay, well, let's get this started here. So just jump in real briefly. We have a lot of content to cover. We have some demos as well, but really just give you an agenda of where we're going to be going through this presentation. Basically, we can talk about some of the introductions, do brief introductions about who we are and where we come from, talk about our motivations in doing this research, and then jump into some of the main core content of this. And we do, like I said, we do have a couple live demos. We're praying that the AV gods and the demo gods are going to be with us this afternoon. But yeah, let's just jump right in. So real brief about me. I've been around in the InfoSec world since the 90s. Really started doing penetration testing back in the 90s. I formed the Spider Labs team at Trustwave in 2005, and have spoken at a bunch of different conferences. It's my third time here at Blackhat, and I spoke 6 times at DEF CON before. My areas of research, data breaches, malware, and mobile, and then also I'm the primary author of the Trustwave Global Security Report that comes out on an annual basis. And you can find me on Twitter as well.
My name's Sean Schulte. I do back-end service development, all right. But I also write mobile apps, and I do malware stuff for Android on the side. Last year I presented at DEF CON. This year was my first time at Blackhat. Okay, so let's jump into really talk about the problem that we're looking at. So mobile malware itself is not really something that makes an appearance very often to the general public. I don't know the last time I don't think I've ever had a friend to me and said, hey, my Android phone or my iPhone has malware on it. General public just doesn't see that. They don't have visibility into that, and they might be walking around the street with malware on their phone, and they have no idea that it's there. Usually when you hear about malware that's being discovered in, say, the Google Play marketplace or iOS, it's usually discovered by a researcher or someone who works for an AV company is typically who finds it. And for the most part, that's not the user's fault. The phones don't have a way to really show you what's running on them. Modern Android phones have the little recent apps button, but a developer can choose not to appear in that list. In the settings, you can find the currently running apps, but again, developers can work around that and not appear in that list. So even if you're trying to be really good and paying really close attention to what's running on your phone, it's pretty hard to tell.
Yeah, and so the other thing with mobile, we know that targeted attacks are happening. We do forensic investigations for clients, and we have had malware that's come our way from mobile devices that have been seemingly targeted attacks against individuals. Things that aren't always happening, things that aren't common malware that you see floating around. But it is sort of the beginning of what we're seeing in this world of mobile malware, and around the corner is probably going to be some more widespread type catastrophe or some widespread type issue that's going to hit not just a few mobile users, but tens of thousands of users. So then also talk a little bit about our experience. So I talked about mobile targeted attacks. You never really hear about them in the media reports. We do investigations a couple of times a year where clients are sending us devices that have malware on them, and that never makes the press. You never see somebody saying, well, our CEO's iPad has malware on it, and it was leaking confidential information from that CEO's iPad. They don't really disclose that, and they won't go and tell the news about it. So you really don't know how many go undetected, or really how many go unreported. But the other piece, sort of even Android or iOS, just mobile devices in general, are really the first type of technology that really, I guess, in my mind, really bridges sort of the digital and physical worlds. So I have my iPhone here. This doesn't really leave my person at any point in time, and it has things like GPS. It's GPS capable. It has a camera, a microphone. It can do a lot of things. It has all my personal information, my contacts, everything else in it,
and a record of all the communication that you perform
with those people. So it's very different than, say, a PC or something along those lines, because it's not always on. And if I take my laptop and put it in the back of a car and it drives off, I'm not going to be able to track where it's at, or someone can't track where that laptop is. So it's very, very different. So I guess in my mind, the mobile world is getting very, very personal to the point where malware has a much bigger impact, or has the capabilities to have a much bigger impact on mobile devices than they do even on the PC or the desktop world.
Meanwhile, for the mobile platform developers like Apple and Google,
they want to get apps in their stores. They want it because it makes them a lot of money. So in these app stores, Apple can keep their barrier to entry really high because people want to get in it. They'll jump through Apple's hoops. But Google wants to catch up, and they've kept their barrier to entry really low for app developers. You don't have to pay as much money. It's not an annual fee. You don't have the 2-week waiting period while they review the app. At first, it just went in right away, and then later, when they found that there was a big malware problem in the Android marketplace, they introduced an automated scanner that they called Bouncer.
So we'll talk a little bit about our motivations. So I guess first off, you talk about Google. Obviously, everybody knows who Google is. They're one of the largest tech companies on the planet. They have great search technology. They have these sort of futuristic research projects that are going on all over the place. But also from an Android perspective, I think 800 to 900,000 devices are being activated every single day. That's a massive population growth that's coming online. And they're also, sort of a footnote here, there's some analysis that was done by asimco.com, a blog that's out there. They published that Android gets about $1.70 per device per year. So if you just sort of do rough math, that's about $400 million in revenue every single year that's flowing in through the Android world.
And it's growing as Android grows.
And then we talk about markets. So historically, the Google market, before now known as Google Play, basically is reactive. So if I'm a malware author and I go and I publish a piece of malware in their market in Google Play, before Bouncer, really the only way that you would hear about end users, malware getting removed from stores, getting removed from the market, was then when an end user would report it or a researcher would report it to them.
Usually it would be a researcher, and then Google verifies that it's malware, and they actively pull it. They pull it off the apps.
Caving in.
But then new malware can come in to replace the old one, and it wasn't effective. It wasn't keeping malware off anyone's phones.
So when you think about that as from a malware, from a criminal, if you have a very low barrier to entry, you don't have to wait weeks, you don't have to pay lots of money to get your malware into a market. This makes it very, very easy for them, and it makes the criminals happy. They don't want to work very hard. They just want to get the job done. So the result of that is you're going to end up with lots of malware and no one detecting it.
And Google realized, I think, that wasn't a battle they were going to win. They can't go faster than the entire world of malware developers. So they needed a way to get the malware out of the store faster and potentially right away before it even got on any user's phones. So they developed this automated scanner that they put into effect late last year, but only announced it in early February this year.
So when we heard about that, Sean and I were actually chatting in our offices, and really the questions sort of popped into our head. We became curious, right? So we wanted to understand things like, now that Bouncer's in place, is that sort of game over for malware? Is malware going to get stopped every single time?
Is it going to be fully effective? Is it going to stop malware completely?
And then we started thinking questions like, well, how difficult would it be to get malware into Google Play? If we decided to go down that route, how long would it take? How much research can we do before someone notices us and cuts us off? And so that was sort of the impetus of sort of this research and what we wanted to start looking into, and that sort of began our adventures in Bouncerland.
So we started from what we know about Bouncer, which was only what Google had told us. They told us that it's totally automated. It scans the app when it's first submitted, and then also later on, potentially based on either time in the market or popularity. If it detects something that's a known exploit, it'll pull the app out of the store immediately. And it also allegedly did behavior-based checking, that it actually runs the app automatically and determines if it's doing something nefarious or bad, and that'll get you tagged. We expected that it was running in an emulator in Google's cloud, and that sounded like it could work pretty well.
Yeah, so I guess when you wear the malware author's hat, so you're sort of looking at it from that perspective, Google Bouncer sounds pretty scary, right? So you're a malware developer, you're trying to get your malware in. From the description, it sounds like it's going to be rather difficult.
And that your old tricks aren't going to work. You can't just, they found my last malware, so I'll just take the same thing, stick it in another app. The old trick where you take a popular paid game, strip the APK out, and release the same game with the same name for free, and then you get people downloading it. That's not going to work as well anymore. So we expected that it wouldn't work, that Bouncer would catch us pretty quickly.
Yeah. So next we're going to talk about the research approach and process. So basically we had to establish some rules. Historically, even Sean and I did some research last year on Android. We had devices and emulators in our labs. And so it's very different when you're doing things with Google Bouncer, right? Because it's Google's. We're not building a Bouncer in our lab. And so really that would mean utilizing Google's resources. So we basically established some rules. Really the first rule we established early on when we were starting this research was that we were not going to attempt to obtain access to Google's infrastructure. We wanted to actually model the same process that application developer would have to follow.
Based partly on an idea that the best way for a malware developer to sneak past and get their malware into the store is by acting as close as possible to a normal developer. Your behavior is not abnormal. If we had broken into Google, the Bouncer server to sneak our malware through, well, they would probably notice that and not let that work.
Yeah, so we specifically noted, I remember like the first day we were talking, we'd say, well, you could attempt to root Google Bouncer, but we decided that would probably be irresponsible and likely illegal. So we did not want to go down that path.
Another thing is that we didn't actually want to be in the business of distributing malware to users. So even though we were going to put an app that we wanted to be malware into the marketplace and we wanted to stay there, we didn't want anyone to download it.
So we'll talk a little bit more, and this is the rule. We're going to talk a little bit more about what we did in order to satisfy that rule, but we really paid close attention to this every step of the way. This was sort of a big portion of our guiding our research. Like Sean said, we did not want something to sort of go wrong and end up with 5,000 users with our app running on their devices. So really, we established some goals. So we wanted to establish a legitimate Android developer account. We also wanted to test the bounds of Bouncer. So we wanted to see when at some point in time would Bouncer catch us, see what type of malware would get caught and what would happen, and then when would we get kicked out. But we also only wanted to use the legitimate tools that were provided in the SDK. We didn't want to try to find some exploit or try to do something that that would actually violate Rule 1 of our research. And then, of course, look for ways, and this became very important, we wanted to look for ways that we can hide malicious functionality. So that if we submitted an application, Google Bouncer would look at the application and think that it's a completely benign app.
Again, we're trying to imagine that we're a malware developer trying to pretend to be a normal developer. So we want to give something to Google that we know they're going to look at, and we want them to conclude that this is a non-malicious, normal application that we're okay with having in our store.
And then, of course, the final goal was to record the results and see how we could make recommendations for improvement. So started out, the first thing we wanted to do was build a completely benign application.
Just put it out there.
We built an app, and we're going to show it to you. Basically, we selected one. This is sort of going with Rule 2. We selected a type of application that was rather common.
That already exists. Competing apps already exist in the store, so it's not some unique and interesting thing that someone might want to check out. And also, the competing apps were either free or cheap. So if we made ours really expensive, that's another reason no one would want to get it.
And then the other piece is that we didn't want to just put together some hello world application and submit it up to Google Bouncer.
Something that's just a screen with no functionality that for some reason requires permissions, that we thought that might raise a red flag, and we didn't necessarily trust that the Bouncer scanner was completely automated, that maybe at some random time someone at Google is looking at these apps. And so we wanted the app to have actual functionality and at least pass muster on a quick check, like, is this actually an app? So
yeah, so the app that we wrote is called SMS Blocksor. And basically it was an SMS blocker. And this is the actual graphics that we ended up uploading to Google. We were required to put an advertisement graphic up. So this is the graphic that I put together that says block any SMS number, no additional carrier fees, simple block, unblock features.
And it turns out that that's a pretty convenient app for us to do this research with, because it's an app that legitimately requires a wide range of different permissions. For example, it needs to be able to read your incoming SMS. It needs to be able to read your existing SMS, your contacts. There are a lot of things that an app like this could legitimately want to do with your permissions. So we wouldn't have some lame app like like let's say we had a game that for some reason needs to read your SMS. That would raise red flags to the user probably when they look at the permissions list.
So basically, if we thought of the problem of, well, if we rewrite an application, a legitimate application that works, like it's advertised to, and we submit it up to Google, and they were going to scan it in their infrastructure, we wanted to potentially have some ability to know when they're scanning it.
Because they told us that it was going to be, and they told everyone that they were going to do behavior-based testing, which we figured means that maybe they'll run the app. And if they are running the app, they probably have access to the internet from those servers. So what we needed to send out like a ping from the app up to our server. So here I created a broadcast receiver that takes that intent, and I use an alarm manager that lets me run lets me run this code whenever I want to. I just specify a time, and it'll run even when the phone screen is off. As you see, the RTC wake up tells it to run even when the screen is off. It's in your pocket. You don't have to do that if you want to try to save your victim's battery life. But with this, it runs repeatedly on an interval, and also will run when the phone boots up or when the app opens. But using the alarm manager technique allows it to not appear in the currently running apps list. Like when you go and take a look at what's running on my phone, it doesn't show up there. The only way to detect that it is run is if you go into the list of all apps and select that one, select this particular app, and if the force stop button is activated, then it has run recently and you can quit it so it won't run again until you open it or restart your phone.
And so basically at this point, all we wanted to do is to see when Google Bouncer was running our application and try to gather some just basic information about that connection. So we have a demo. Really, this is a real quick one just to show you
what the app looks like.
There's a little bit of a delay there. This is actually the app that's running on the phone.
This app is running on the phone right here. There's not much to this demo. We're not really going to use it.
Basically, you would enter in a phone number to block, and then if I was to send a text message from that phone number to this device, it would just not show up. And there's a lot of other apps out there in the market that do the same exact functionality.
So that's the app that we made, and it got into the marketplace. And at that point, with no malicious functionality, it's kind of boring. But we needed to get into the marketplace first.
Yeah, so we decided, hey, we have this app running, works great, let's get it published. So I went and actually created an Google Android developer account. That wasn't very difficult. It took all of a couple of minutes, and it cost $25 to create that. And then also when we started trying to prep this up and try to put it in the market, we realized we want to sell the app. So that took an extra step. I actually had to create a Google checkout merchant account in order to be able to actually even put a price.
Also easy, it's just another thing to do.
Yeah, it didn't take very long. I think the whole time was about less than 60 minutes from start to finish for me to create an account and then have the ability to publish the app in the store.
And then as soon as that was done, we just uploaded the APK and it was in the market.
As you can see there.
And as we mentioned, we made it expensive. We made it cost $50, and that prevented anyone from wanting it. But we uploaded it, it was in the store, and a couple minutes later we got a hit on our control server from Google. That 74.125 IP block is owned by Google and is from California, I believe. And something that I thought was notable about this is that it's pretending to be an actual phone. The emulator does not claim to be an HTC MyTouch 3G running on T-Mobile. It very clearly indicates that it's an emulator.
Yeah, and at that point we knew a lot more. We actually knew a lot more about Bouncer just from that one exercise. We knew that it actually was automated. It did scan within a matter of minutes after publishing the application. And then we knew the IP addresses belonged to Google. So we didn't want to trust that this was going to happen the exact same way every single time. So
that was just the first time we'd uploaded it. We didn't, maybe they just scan it once, it looks good. We needed to make sure they're going to scan on updates. So we made a trivial update to the app. No real added functionality, but we uploaded it again, and it scanned us again just a couple minutes later from a different IP address in the same IP block.
And as you can see, we just took a screenshot here. There's
this
SMS.
Is before they changed it to Google Play.
This is SMS Boxer in the marketplace for $49.95.
That buy button is pretty tempting, you guys.
So now at this point, we knew where Bouncer lived. So we knew that much about him. So and then But then, so at this point, we decided to make, we're really trying to explore the way to hide or to hide the malicious functionality from Google Bouncer.
Because we're trying to get past Bouncer, so we want to make sure that when Google's scanning it, it remains a non-malicious app. They never see anything bad. But then if you put it on your phone, it becomes malware.
Right, and that's basically what we did. I mean, there was just two phases at this point. And then we also, as a precaution, we actually defined sort of everybody else. So if Google ran it, it would not exhibit the malicious behavior. If we ran it, it would. But we defined everybody else as really the TrustWave network. So
we wanted to make sure we had a blacklist and a whitelist. Not really necessary for real malware authors, but we're trying to be careful to obey Rule 2.
And then, we also wanted, and so, this is one point here, is that if there was a manual review going on, with that code in there, and so we could probably we'll talk a little bit more about this, but we turned to a legitimate technique that was being used by some other applications out there to be able to make the switch so that so that we can actually dynamically turn on malicious functionality throughout the life cycle of the app.
So we realized that a lot of apps, including popular ones like Facebook, Netflix, etc., use HTML and JavaScript to form their actual application, and they put it in a native wrapper so it can be downloaded from the app stores, installed, and look like a normal app on the phone. But what this means is that the JavaScript that they're using can access the native platform's SDK and your personal data. Facebook can push down an update over the internet without using the platform's app update. They can give added functionality to the app, which means they're downloading JavaScript and executing it on the device. If they can use it for a legitimate reason, we could use it for an illegitimate reason, and use this JavaScript bridge for making malware. And basically, if Facebook and Netflix can do it, that means any app that is allowed to use this JavaScript bridge can become malware at any time after it's installed on someone's phone.
Yeah, and that's a big point there. I think most users don't know that they go and download an application today, and if they decide, well, I'm never going to update that application, the application actually can be updated. And it could be additional legitimate functionality, but as a malware author, that actually gives you timeline. So you can distribute a popular application today, and then not enable any malicious functionality into it from a year from now, if you wanted to.
So we figured it seemed possible, and so we decided to try it. And Android actually makes it pretty easy. You just fire up a web view, which you don't have to display. We just have it running in memory. And you turn on the JavaScript bridge. Do I have a mouse here? Just say add JavaScript interface, and you give it this bridge object that just contains the functionality you want. And what we wanted to do was make sure that we always called this bridge object either directly or through JavaScript locally on the phone in the app's normal execution, as well as when we download nefarious code from the internet, so that we're executing the same code paths. If Bouncer is doing some cool static analysis of what the app is doing, or will probably do.
So yeah, so one of our goals was avoiding detection. Obviously, we wanted to try to get an application that through Google Bouncer that can be malicious on a end user's device. So one thing that we did in developing SMS Blockser is that for every piece of legitimate functionality, it had a corresponding malicious functionality that was in the app. And we'll actually, one of the next slides, we're going to show you a chart there. But one thing we also did, that callback server that we talked about earlier, that basically essentially became a command and control server for us. And so when it would phone home, when the application would phone home, and it would actually be able to dynamically download its instructions for it to execute when we wanted it to. So here are all the various versions, and these are all the versions we uploaded over the course of several days. But basically, really at a high level, so you can see in that left-hand column there where it says legit, that's all the legitimate functionality that we included in the application. So things like selecting block numbers from your contacts. The malicious side was stealing all your contacts. And we also included when we uploaded it each time, when Google Bouncer scanned it and if it detected any issues with it. And actually, one thing to note is that phase 3, which was see your phone number, and then it was complete phone recon, for whatever reason, during that test, they never scanned us, and it was still published in the store.
And we decided to go with this somewhat iterative approach, step by step, because we wanted to see if there was one of these that Google would catch. Like, all of a sudden we're have this new photos functionality, or reading all the phone records. Is that going to stop us? Or if we just done it all at once, we're not going to get all the information we wanted. We kind of expected that one of these steps, like the hijacking the screen, which doesn't really have a reason to exist, or the DDoS attack at the end, we thought that would get us caught. So we didn't want to have that in the original published app. Of course, it didn't get caught. So here's a quick screenshot of the interface for our control server.
We're going to demo that in a little bit.
We'll show that in a little bit.
So then, we went through this whole process, and as you can see in that chart, sort of the final functionality was sort of this denial of service functionality that we can actually tell someone running that app to send a lot of connections to a host. Now, obviously, one-to-one isn't very exciting. If it's only one app, one phone running this, and you decide to send 10,000 connections to a website, big deal. But in the real world, when this malware gets deployed out there, malware like this gets out there, you're not talking about one user running it. If it's a popular game, you can end up with lots of end users.
I mean, apps get popular. I have an app in the store that has 55,000 active users. Just regular people can make popular apps. But we hadn't originally planned to have the hijacking the screen and the DDoS functionality in it. We thought we'd get caught before that. So after nothing else got caught, we were kind of brainstorming, well, what else can we throw in there? They have to catch something. So after they didn't catch those, we decided, well, we need to step up our getting caught game. So we removed the bouncer blacklist and submitted another version of the app, just a small tweak that was the complete app, but it served the malicious payload to Google, and it executed that payload on the bouncer scanner.
And it
still didn't work.
And they still didn't catch us.
So we decided to be even more aggressive. Instead of calling back out to the control server every 15 minutes, we decided to go down to every 1 second. So we submitted an app that as soon as they open it, just starts slamming slamming the network with all the device's personal information. It's uploading the photos, it's uploading the contacts and phone records and everything. And Bouncer noticed that was happening.
You got very angry.
It scanned us a bunch of times. Like the first scan, we got several calls back, and then 6 minutes later, and then it stopped. 6 minutes later, after nothing had happened for a few minutes, it scanned again. Again, stopped after just 30 seconds, and then went away. But it gave us some kind of cool information because it had contacts, one of which was the White House. It has a phone number, which I assume is fake. And what I thought was interesting is that this emulator is running, it claims to have a SIM serial number. Like the actual Android emulator that I have, a lot of this is null. It doesn't have a phone number or a SIM card. But then 24 hours later, we got this. And that first scan tipped them off. The second scan was some sort of verification. And a day later, they pulled the app from the store and terminated the developer account. So this is what happens when the bouncer actually catches you.
Right. And one thing to note is even though when that scanning was going on, it was about 24 hours until we received this email. And so during that time, it was still in the store.
Even when the app is caught and is verified to be malware or at least heavily suspected by Bouncer to be malware, it's still in the store for, in this case, 24 hours.
Right. So now we have our sort of the SMS Blockster evil demo that we're going to go through. And this is where we have, and just to give you a sort of setup here, we actually have a device here running SMS Blockster. This is actually the only device that ever bought that copy of Blockster. I paid $49.95 to get it onto this device through that process. So we're going to show you a couple of things. We have obviously the phone here, and you could. Oh, you already seen the phone, seen it running.
And it's not going to do anything. This runs in the background, so the phone itself, it can be off. It's just on the home screen. The phone itself is doing nothing that the user can see.
So
right now we have it checking in every 5 seconds because this is demo mode. Normally we wouldn't want it to ping us all the time that would probably not be good for the user's battery life, and they might notice.
So one thing you can notice at the bottom of the screen, that's it actually checking in. And so this will auto-refresh as it checks in if everything's working correctly. These are always pray. And you can see that it has an X now in the recon box. So it checked in, it sent us phone recon information.
So we fire that up and we see that this phone has a phone number, voicemail. We now know the SIM serial number off the phone, the device ID. So that's kind of cool stuff. And we know the IP address it's coming from. In this case, I think that's AT&T, because we're tethering to the iPhone to get internet in here.
So now we could turn on some other functionality. Turn on contacts.
Say now we want to get some contacts. We'll wait for it to ping that back for us.
Yep, there you go.
Go.
So it grab contacts as well.
So here's some phone numbers. We're scrubbing them for you so you don't start calling us.
We could turn on phone records. And I've actually been using this phone all week here in Vegas. So I've been, if any Spider Labs members are in the audience, if you got text messages from some stranger who was asking you lots of questions, that was me from this test phone. So we wanted to get some SMS conversations going on.
So in here, as you can see, there are there's some phone calls. Android doesn't, for some reason, record the calls and let you upload the audio, but we know who and when you made and received calls.
So we could.
But it does keep a record of all your text messages. So that's the next thing we're going to download off this phone.
Yep. So it should be updating shortly.
There you go.
And there you go. Now we got all 4.
So here are a bunch of texts that Nick was texting people all week. Just pulls them right out, incoming and outgoing.
Yep. So the other interesting thing, we're also able to grab photos off the phone. And you might want to. There's also not we don't actually ask for that permission.
Yeah, I never had to ask for photos permission. That just came along with something, but we can grab photos without the user ever seeing that we're going to use photos in the permissions dialog. I was kind of surprised by that. It seems like an oversight. That's me preparing for the talk.
Give it on random. And then one thing to note, if you see over on the right-hand side, you see that 5 there? That's actually, when it checks in, it actually records then the next time it should phone back in.
So we can change that interval. We can have it checking in every hour, and then we want to start doing stuff, changing stuff. We can tell the phones, start checking in every minute for a while, and then we can switch it back when we've gotten what we wanted to.
So then the other functionality, and so there's some random photo from here. So the other functionality that we thought would be pretty interesting, this comes a little bit from a talk that we gave last year at DEF CON, where we talked about a vulnerability in Android called a focus stealing vulnerability. So basically, what Sean's going to do, he's actually going to put a URL into this hijack, and it's going to send it down to the device next time it checks in, and without the user sort of interacting with the device, it's going to just pop up a web page on the user's device without them really knowing what's going on, and it's popped up here and it refreshes.
So we can send all those users, all those phones, to whatever website we want to, essentially whenever we want to, which opens up some interesting stuff. Like if it comes out that there's a new WebKit vulnerability that we want to use that we want to exploit to root your phone, we can just send your phone to that site without you having to click on anything and use the exploit.
Yeah, so it sort of creates an interesting concept in, I guess, mobile malware. You're sort of future-proofing your malware. So you add this functionality with hopes that there is a...
With no knowledge of any existing WebKit exploits, but then when one is discovered and before it's patched, you can immediately send this out to everyone.
Right. And then the other thing you could do with this, obviously, you can send, an end user just opens up their phone and they see a login page for something. With hopes that they're just going to enter in their login information.
It's possible, right? Yeah.
And then the last bit of functionality that we added, and this was where Sean was saying that, so we actually, I think you could shell into that server, but we actually created basically botnet functionality, what we called botnet functionality. So we sort of envisioned if this became if we say wrote a popular video game or something, and we published it in the store, and then a day later, it gets 2 users, and then a month later it's 5,000 users, and then a few weeks later after that it's hundreds of hundreds of thousands of users. you now basically have a whole bunch of mobile devices that you can then direct to run basically a denial of service attack against anybody you want. So we wanted to put that functionality into there.
Yeah, your AT&T connection's not helping my SSH.
There we go.
Yeah, there we go. We just told it to start slamming this website. And, if you can see the seconds number occasionally changes, it's sending a lot of requests right now.
I think it's designed, we designed this to send, what, 12,000?
It'll send 12,000 every time it gets a check-in, and right now it's getting a check-in every 5 seconds, so it's sending a lot of requests. AT&T is probably going to complain about that. I'm going to stop doing that.
Yeah, so the other interesting functionality, just at least in this command and control, we're able to do things like clear all and turn everything off. And so if you turn everything off, the next time it checks in, which should be in a couple seconds, you'll actually see the X's clear out. So it will stop sending its functionality. And the thing to note, on this phone here, there was, besides that hijack functionality where you actually saw something pop up on the screen, this phone's been sitting here and the app hasn't even been opened. And nothing, there's no indication at all that the photos were taken, that contacts were being taken, that text messages were being taken off the phone, or even the DDoS or the denial of service was launched. Basically, you can imagine an end user, and this is what we were talking about at the beginning of this talk about visibility. An end user could have this on their phone and would have no idea that this functionality is happening, these activities happening on their device.
It looks like the phone is a little swamped right now with doing that DDoS, but before we go on, just want to show what it's downloading here. This is the JavaScript that we're sending down to the phone. Right now, I've turned everything off, so I'm telling the phone to stop sending me the phone info, stop sending me the contacts, stop sending me the photos. But if I had turned it on, it would tell it to send it. And note here that it happens in the on load. So as soon as the JavaScript downloads, that this code will execute. And usually, if we're not sending anything malicious, the only thing it says is set the number of seconds till the next time I check in, which the device holds in memory. And here we go. It looks like it's
finally
come
checked
through
in.
and turned off. So it caught up and managed to download it.
So go back into the presentation here. So really what we learned about Bouncer is that everything that Google said was true. So everything they said about the analysis, about it being automated, and we found that to be true. But then through our research, we found its main weakness is that malware developers can design their malware to not execute when it's being run by Google Bouncer.
Because we know that Google's going to scan it when we upload it, so we know not to serve anything malicious then, but we also know where they're scanning from. So even if we had been serving malicious payload, well, we know that if you're coming from 74.125, you shouldn't see that. And so we just have on the server, don't ever send it to them. So if they're going to scan the app again after it's gotten popular, they're still not going to see that it has anything malicious in it, and they're not going to see it doing anything malicious.
I mean, also if you think about the concept of this JavaScript bridge being used, it really allows developers to really bypass the whole certification process of an application. So if you consider just a process of a pre-entry review of an application, and someone puts a seal of approval on it, it's now able for users to download. As a developer, I can say, well, it was certified, or not certified, but it was checked, and it was allowed with this functionality. Well, a week later, I could just dynamically change that functionality.
That's
completely.
basically the point of Google requiring the code sign, and then when you download the app from Google Play, you get it comes over HTTP. The app itself is not encrypted, but there's an HTTPS connection that after it finishes downloading, that asks for the signature, and then Google Play tells you the signature of the app. Verifies that the app has not been tampered with, the functionality has not changed. This is the app, this is the functionality of the app that was intended to be there, and we've scanned it and have found no malware. That's the point of that. However, any developer, and it's not hard, I mean, there's no big trick here, can get around that code signing and can execute whatever code they want to, whenever they want to, just from the internet.
So we sat down after we completed this process and thought, what are some ways that a bouncer type system can be improved, and there are ways, right? So a better bouncer would consist of other entry and endpoint evaluations. And so when we talk about endpoint evaluations, we talked about visibility and the control that end users have on their phones. The end users have no ability to verify or even identify if there's nefarious activity going on their device.
And not only the user, it would be hard to train the users to search for malware, but it would be useful if some sort of malware scanning were happening on the device, that if a part of Bouncer was running on your phone, and if suddenly an app changed what it had ever done before and started uploading your contacts to an unknown site, that it might report back to Google that this app needs to be checked out. And is this happening on other devices also?
Right, right. So the idea of requiring developers to submit something like a functionality map of their application that then gets verified by a Bouncer system and then passed along down with the app to the device, so the device can self-police that activity is going on, just as the scenario that Sean just spoke about.
I'd also like to see that behavioral testing seems to only run for about 30 seconds. I mean, if you're going to try to be really simple about it, maybe you just not activate the malware for 5 minutes, and then the behavioral scanning never catches that. We didn't bother trying that, so maybe that doesn't quite work. But these are things that I hope the Bouncer team is evaluating. Also, it would be helpful if they scanned from different places. It was always scanning from the same IP block, and the IP block is owned by Google. If they I don't know, talk to AT&T and Verizon and we're getting scans from them, well, we couldn't just blacklist that because then we're cutting off actual victims.
Right, right. And then the other idea is, the JavaScript bridge, that capability must be strictly limited.
Yeah, we learned a long time ago, and by we I mean everyone, that downloading unsigned, untrusted code from the internet and executing it with full permissions on the device is a terrible idea. And they should be working to prevent that from happening, essentially ever.
So I guess we have some conclusions, some things in conclusion here. So, this is not just a problem for Google and Google's Bouncer. There are lots of other app stores out there today. There's enterprises. I talk to enterprises on a regular basis who are planning on building their own private app stores. The U.S. government has built their own private app store. So this is not just a Google issue. The issue is that if you're only going to scan applications at entry, and not be able to have visibility down at the end user's devices, this problem will continue to exist. And the other piece is, application markets with automated malware detection. If the malware authors are spend enough time, or they spend the same amount of effort that Sean and I spent on this research, they actually they will be able to beat an automated system.
And we realized at the end of this testing that there's no reason they couldn't beat a manual check too. If you never supply malicious functionality to the app, then a manual reviewer is just going to see your app. And in our case, they would see that it's kind of crappy, but that doesn't stop a lot of apps from getting into the app stores.
Right, right. And then the final conclusion is, really pushing the industry towards doing this type of detection on the endpoints themselves, on the devices, because end users need to have visibility, or at least have devices that have visibility into what's going on within these applications, or this problem will continue to exist as well. So
basically, Google's done a good job. Bouncer seems to be effective, but there's always going to be ways to get around it. There's a lot of functionality that's possible on an Android device, and with that power comes a lot of ways to use it inappropriately.
Right. So I think with that, we have some time for some questions. A couple of minutes. Yeah. No. There was no notification to us as an end user, I guess as a customer of SMS Blockser. Oh, sorry. Yeah, his question was after we got kicked out of the Google Play market, did any notification get sent down to our device? The device that actually bought the app, and the answer is no. So as a customer, if the application was found malicious and pulled, it would basically, as an end user, you had no indication that was going on. Yeah.
The question is, did we submit the app to another app store like Amazon? And no, we didn't. We should have, but this was a talk about Bouncer itself, not app stores in general, although that probably would have been a good idea.
Hey. Yeah, question over there.
past?
No, we didn't.
The question is, did we try to reactivate the account or create a different account? Google actually says in the termination letter, don't bother trying to reactivate it, or don't bother trying to resubmit it. You can appeal your termination, and then we'll get back to you. But I mean,
I actually
that never happens.
actually did attempt to appeal, and never heard anything back.
Sounds about right.
No, it never made it into our account. So, yes.
We did not. The question was, did we create another account and submit the same app again to see if Bouncer developed a signature of that application and knows it from now on? No, we didn't. We couldn't get anyone to volunteer to give us their Google account, and and I don't think we wanted to start creating fake identities or anything.
Hi, this is Zach Lanier. Number one, if Google does actually pull down a malicious app from users' devices, they will be notified. They'll get a notification saying it's been revoked remotely. But my question was, did you find cat.jpg?
No, we did not.
Were you aware of cat.jpg?
Yes.
Excellent.
I have sort of a broader question. Isn't the underlying issue here something that a piece of automated testing software like Bouncer can't really resolve? That the Android permissions model is far too coarse-grained and that it doesn't really do anything like track the creators of data and require data creators to authorize data users? I mean, there are full-blown machine simulators in Google Play, and you can't imagine they're going to take down every copy of SimAge and so forth. I mean, how can anything like Bouncer ever work with the security model the way it is?
I think that's a much larger question that I don't think I'm prepared to address.
In terms of running Bouncer on the actual phones themselves, okay, obviously that's not possible right now, but did you try any of the tools like Lookout or anything like that to see if those would detect any kind of malicious behavior for the tool itself?
No, we did not.
Okay.
Yeah.
Just curious.
Google obviously used your app. Do they pay for it?
No, they don't.
No, when the scanner runs, they don't pay you every time you upload an update to the app.
It actually doesn't show up that it's ever been used. So for a long period of time, it had 0 downloads, even though they were scanning it.
Which, I mean, I would expect that's how it should behave.
For the hijacking functionality, why would you want to send a user to a malicious web page to exploit a WebKit bug if you already have code execution?
We don't have full code execution. We're just sending JavaScript that can interface with the existing SDK. Being able to root the phone gives you more power, and that's not something that we attempted to do with this app. And we wouldn't try to get that past Bouncer.
I mean, popping WebKit's not going to get you root either.
So kind of on the same lines, I mean, I would imagine with the current model that Android has, malware authors might want to pull down stuff. I think I've seen where people were pulling down Rage Against the Cage or whatever, or the X-Ray app that John Oberheide just released. So I almost wonder, why would you even worry with this JavaScript bridge when you can just pull down arbitrary binary blobs that, there's no code signature checks and just run whatever you want?
Well, there's always 2 ways to skin a cat, right?
That's true. I mean, I just feel like, that's another interesting vector that Bouncer should check. I mean, how many legitimate apps are going to be pulling down a binary and executing them? AV apps might pull down a signature, but they're not going to execute the signature. So. Well,
games will often pull down extra artwork. I mean,
do you execute JPEGs often? I mean, I get your point though, right? Like there are things that are going to get pulled down, but I feel like there are some things that are behavioral that Google could probably also pull pretty easily.
Like preventing it from being able to execute the code that's downloaded?
Yeah, I mean, it could, or it could at least flag it for manual review later. It's not a foolproof thing, right? Because you could just send a JPEG, or if it's from Google, but just thoughts.
There was a question over here. No. Yeah, so the question was, once our application was removed from the marketplace, did they remove the malware from our device? And the answer is no.
Well, we can't say for sure that it didn't get remote killed. I assume it did, but we were running a test version of the app on the phone itself.
Right.
Are there any other questions?
Yeah, question in the back there. No, they did not. Sorry, the question was the device that we downloaded and purchased it on, did it get removed from that? And the answer is no. Yeah, question?
I would say that JavaScript that's downloaded from the internet and is untrusted and unsigned shouldn't have as much access to the SDK as it does. That maybe there's some way to make it so that it can change the way the interface looks or change around the functionality without accessing the context database. The JavaScript shouldn't get access to that. And I don't know about implementation details or if there's a better way to do that. But that would be my first pass at a piece of advice for them.
Yeah, he was asking about the why we got kicked out or why they caught us, and it seemed like it was. He mentioned it seemed like it was because of the frequency of the requests.
Well, I'm guessing it was because that behavior seems clearly malicious. That as soon as the app starts, it just repeatedly uploads all your contacts and phone records and SMS records every second. That's something that the bouncer absolutely should flag as malware. We were trying to get caught with that one.
Yeah, we could. Well, I guess we can discuss that. We had not made it publicly available. Yeah.
Well, it's tough to say because we only got caught once, and it was when we finally made something that just needs to get caught. So, as he alluded to, it could be just the huge amount of network traffic or just uploading the personal data repeatedly. But without more testing and a lot more apps and a lot more Google accounts, it'd be impossible to say that we know with any certainty what Google's actually looking for. You should start practicing your JavaScript bridge. Oh, what should he as a malware author take away from how he could make better malware?
Well, yeah, the question was why didn't we get the cat.jpg? During that test, the information that we showed you was what we got back. We don't know if that specific instance didn't have that image on it, we don't really know why we didn't get it back. We get images back from our real devices, but we didn't get an image back from their test device.
Well, it asked for the external storage and got the list of photos. However, it may make a difference that we didn't ask for photos permission. So we were getting photos that were available without permission. Yeah, well, we weren't reading the SD card directly. Yeah, it just uses it allows you to execute the Java code from JavaScript. So the JavaScript can do what the Java code can, but it doesn't escalate.
Sorry, can you repeat it?
We really have no way of knowing that bouncer. It could have been something else.
Outside of the bouncer system that caught it? Yeah, we don't know. We sort of define bouncer as the system itself. So if Google has some other controls in place that are looking for that traffic or something that's what caught it, it may have been.
I would imagine that they would define that as part of bouncer. Was that a cute joke? No. Okay.
Okay.
Well, I don't know if we could see evidence of that, but we assume that it was happening. Is that all? Seems to be all. Thank you.
Okay, thank you.